Hey there, deep divers. So today we're going to be looking at C3 linearization. You shared some really interesting sources with us, academic papers, Wikipedia articles. I even saw some blog posts from programmers.
It's a fascinating algorithm, really, used in object-oriented programming languages.
And even if you aren't a programmer, I think that you'll get some interesting insights from this deep dive because, who doesn't love a good system?
Right?
C3 is all about creating order and predictability even when things get complicated. So let's dive into that complexity first, okay? What exactly is C3 trying to solve?
Well, it addresses this problem that arises in object-oriented programming called multiple inheritance ambiguity.
Multiple inheritance ambiguity.
Yeah, so imagine you have these bits of code, they're called classes, and they inherit characteristics from their parent classes. Makes sense so far, right?
Yeah, it's like a family tree for code.
It is. It is like a family tree, but for code. The problem is, what happens when a class has multiple parents?
Okay, I see where this is going. In a family tree, that could lead to some awkward family reunions, for sure. But in code, what's the issue? What's the big deal?
Well, you can run into conflicts.
Okay.
Let's say you have a class called Smoothie that inherits from both a fruit class and a dessert class.
That sounds delicious already.
Right. What happens if both fruit and dessert have a method called prepare?
Okay.
Which prepare method does the smoothie class use?
Yeah, that does sound like a recipe for confusion.
Yeah.
So C3 comes in to kind of settle those inheritance disputes?
Exactly. C3 linearization provides a very clear set of rules, to determine which parent class's method takes priority.
Okay.
It's like establishing a pecking order to resolve those conflicts. This order, we call it the method resolution order, or MRO.
The MRO.
And C3's MRO, this isn't arbitrary. It's designed to be very consistent and predictable.
So programmers don't get any surprises when they're writing code. No sudden plot twists.
Exactly. Now, how it actually works can get a bit technical, but imagine you have a bunch of lists, okay, each representing the inheritance chain for a parent class. C3 uses a method similar to merge sort, you're familiar with merge sort,
Yeah.
to combine those lists into one big unambiguous order.
Okay. I'm following so far. We've got the problem, multiple inheritance ambiguity,
Yeah.
and we've got our solution, which is C3 and its very elegant ordering system.
Yes.
But can you give us a real-world example of where this actually plays out?
Absolutely. Let's look at a computational system called SageMath.
Okay.
You familiar with this?
I am, yeah.
It's used by mathematicians and scientists to model all sorts of complex mathematical concepts. And because math is all about relationships between things, SageMath relies heavily on this idea of multiple inheritance. For example, a ring in mathematics might also be an algebra, which itself is a type of set, and so on.
So it's like creating a family tree for mathematical objects.
Yeah.
That sounds pretty complex, and I'm guessing that's where C3 comes in.
Right. At first glance, it seems like a perfect fit. C3 swoops in, sorts out all those inheritance relationships, and everyone's happy. But it turns out that C3, while incredibly useful, isn't always a perfect solution.
Oh, I'm intrigued. What happens in those cases? What happens when it doesn't work out?
Well, sometimes those local decisions that C3 makes, based on the immediate parent classes, can clash with the desired global order of things.
Okay.
Let's go back to the ring example. In SageMath, you want the ring class to behave primarily as a ring, even though it inherits from other mathematical structures.
So even with C3, there's a potential for conflict?
A little bit, yeah.
I'm guessing that created some headaches for the SageMath developers.
You could say that. But instead of abandoning C3 altogether, they came up with a really clever workaround.
So they found a way to make C3 work for them. How did they pull that off?
They basically gave C3 a little extra guidance, just to nudge it in the right direction. It's like adding some well-placed signs along a hiking trail, to make sure that everyone reaches the intended destination.
So they didn't have to rewrite the whole algorithm, just give it a little boost.
Precisely. They strategically added some extra inheritance links, even if they seemed at first glance a bit redundant. And the beauty of this approach is that it works within C3's existing framework. No need to reinvent the wheel.
That's fascinating. So they essentially taught C3 to see the bigger picture.
Exactly. They gave it just enough information to resolve those conflicts and ensure that the final order, aligned with the overall structure of SageMath. This reminds me of how we organize information in the real world. Take libraries, for example.
Okay.
The Dewey Decimal System.
Yeah.
It's designed to create order out of chaos, right?
Right.
But even that system needs tweaking sometimes to accommodate new types of knowledge.
That's a great point. We create systems to manage complexity, but those systems also need to be flexible enough to adapt to change, right?
Yes.
Otherwise, they break down. It's like trying to fit a square peg into a round hole.
And that's a key takeaway here. Algorithm design, just like any system design, involves finding that balance.
Yeah.
You want it to be robust, you want it to be predictable, but also adaptable enough to handle new challenges. The SageMath developers found that balance with C3, and it's a great example of how a little ingenuity can go a long way.
Yeah, I'm starting to see how these, what seem like technical concepts from computer science, have implications that go far beyond programming, right? It's about how we approach complexity in all aspects of our lives.
Absolutely. C3 linearization might seem like a very specific solution to a niche problem, but it highlights this fundamental challenge that we all face. How do we create systems that can manage complexity while remaining flexible enough to adapt to new information, to evolving requirements?
So it's about finding that sweet spot between order and adaptability.
Right.
Whether we're talking about code, libraries, or even our own personal lives, that balance is crucial.
Exactly. And what's fascinating is that we often draw inspiration from the natural world when designing these systems.
Yeah.
Think about the way hierarchies exist in nature, right?
Yeah.
From ecosystems to ant colonies, there's a very clear order, but also an amazing ability to adapt to change.
It's like nature has already figured out some of these problems, and we're just catching up.
In a way, yes. And the more we understand these underlying principles, the better equipped we'll be to create systems that are both robust and resilient.
So from messy inheritance chains to the Dewey Decimal System, it all comes down to finding ways to manage complexity. It sounds like C3 linearization is just one example of how we're constantly striving to create order out of chaos.
It really is. And the more we understand these systems, the better we can navigate the complexities of our world. But let's bring this back to you, the listener.
Okay.
Have you ever encountered a system that just didn't seem to work? Maybe it was too rigid, too complicated, or just didn't adapt to your needs.
Oh, I've definitely been there. That time I tried to organize my entire life using a color-coded spreadsheet. Let's just say it didn't go as planned.
We've all been there. And those experiences can be incredibly frustrating, but they also offer valuable lessons. They teach us that no system is perfect, that flexibility and adaptability are just as important as structure and order.
So what can we learn from C3 linearization and these other systems we've been discussing? What are the key takeaways for our listeners?
I think one of the biggest takeaways is that complexity is inevitable.
Okay.
Whether we're dealing with code, organizations, or even our own personal lives, we're constantly encountering situations that challenge our ability to create order, to make sense of things.
So it's not about avoiding complexity altogether.
Exactly. It's about developing strategies to manage it effectively. And that means understanding the principles behind good system design, like the ones we see in C3 linearization. We need to find that balance between structure and flexibility, between predictability and adaptability.
It sounds like we're all system designers in our own way.
Absolutely. And understanding those underlying principles can empower us to create more effective systems in all areas of our lives.
This has been a fascinating deep dive. We've gone from the intricacies of C3 linearization to the broader implications of system design. And I think it's safe to say we've all learned something new today.
Yeah, it really has. I think what struck me most is that these seemingly technical concepts from computer science, like C3 linearization, actually have a lot to teach us about how we approach complexity in the real world, you know?
It's true, yeah. These algorithms offer us a new perspective, a new lens through which to view how we structure our thinking, how we make decisions, how we build systems to manage the inevitable chaos of life.
So as you go about your day, listeners, think about the systems you encounter
Right.
at work, in your community, or even in your own head, right?
Yeah.
Are they working for you? Could they be improved?
And consider this. What can you learn from the principles behind C3 linearization?
Yeah.
How can you apply those ideas to your own life? Maybe it's about creating a more efficient workflow, or streamlining a process, or just finding a better way to organize that to-do list. That's a great point. We can all be system designers in our own way, right? Finding that balance between order and adaptability.
Exactly. And who knows, maybe you'll even come up with a clever workaround of your own for one of your own personal system challenges.
Well, that's a wrap on this deep dive into C3 linearization. We hope you surfaced with a newfound appreciation for the hidden connections between computer science and everyday life.
And remember, there's always more to explore, more to learn, and more to discover. So keep asking questions, keep digging deeper, and keep diving into the fascinating world of knowledge.